Hey guys, so today we'll be solving the LeetCode problem Unique Paths II. So the problem states you were given an n by n integer array grid. There is a robot initially located at the top left corner, so we're going to start at the top left corner. The robot tries to move to the bottom right corner. The robot can only move either down or right at any point in time. So we know we need to go from the top left corner to the bottom right corner, and we're only allowed to go down or right. An obstacle and space are marked as 1 or 0 respectively in the grid. A path that the robot takes cannot include any squared as an obstacle. Return the number of unique paths that the robot can take to reach the bottom right corner. The test cases are generated so that the answers will be less than or equals to 2 times 10. 2 times 10 raised to the power of 9. So we know we're trying to go to the top left corner, find the number of unique paths that the robot can take from the top left corner to the bottom right corner. And each path that we include in the solution must not include an obstacle. So from this part which states that the number of unique paths that the robots can take, I already know like it's a dynamic programming question in which you probably need to use, the way I like to solve my dynamic programming problems is that I like to use recursion because it's more intuitive. So for this problem, we know that at each point in time, the robot can either go left or right, and after we go left and right, we know that this step is valid if it's not an obstacle or if we don't go outside of the grid, and we're going to go left and right until we can reach our goal, which is the bottom right corner of the grid. So yeah, that's how you solve the problem. Yeah. So we're gonna go public int BFS. So we are gonna pass in the rows here, the current row we're on, int the current column. So we're first gonna check if for a valid solution, which is a row, no if grid is if row is equals to row len -1 and call is equals to call len -1. That means we've reached the bottom right corner, so we're going to return 1. Yeah, so now I have to check for the invalid cases. This is the valid case. So the invalid case is if the row we are on is greater than row.len, or the call we are on is greater than call.len, is greater than call.len. It is not a unique path, so we're going to return 0. And if the grid at that point, if we've reached an obstacle, so we also return 0. If grid row call, we're going to call is equals to 1, return 0. So int paths, which is the recursive case, is going to be this. After that, we're going to return the paths. Yeah. So this would be the recursive solution without memorization, without storing the paths we've already traversed. So in order to prevent repeated work from being done, we need to basically store already calculated paths that we've traversed in an array. So yeah, so we're going to have like a store paths array that basically stores the row call is equals to paths. So here, so before we recurse, we're going to say if store paths row call is greater than 0, is greater than 0, we're going to return it. Return it, yep. Also, if it is else, if it is less than 0, it is less than 0, we're going to return, when we're going to return the value, we're going to return 0. What else are we missing? So for the store paths row call, we need to store the value when an obstacle is reached. We're going to store it as equals to -1. We are going to store it as -1 because like when I initially create this array, all the values are going to be 0, 0. So in order to know that, oh, I've already reached that point, I'm going to change the value to -1. Yeah. Yeah. I think, yeah, so I just need to create all these variables, which is going to be private int roll_n, private call_n, private int grades, which is a copy of the grade, private int store paths, which is for memorization. I'm going to say roll_n, initialization of values is going to be equals to obstacle grade dot length call_n is equals to the same thing, but yeah, a particular row. Grade is just a copy of the obstacle grid, and what else? Store paths is going to be the same size as the obstacle grid, so we're going to be equals to new int roll_n and call_n, and after which we're going to return this solution should be correct. Hopefully it works. Let's see. Oh yeah, and then we submit. Let's see. Yeah, passed all the test cases. Yeah.